Okay. Hello, everyone, and welcome to the first seminar of NetPlace of the season. Today with us, we have Elena Candellone, that is a very active part of the community, as reflected in her soon-to-come discussion topic. But first, she will talk to us about negative ties in online social interaction, and I should have started with this. Elena is a PhD candidate at Utrecht University in the Netherlands. So with this mixed order presentation, I think I can give you the stage, Elena, and we are here to listen your talk.
Thanks, Alessia, for the introduction. And yeah, so I'm as Alessia said, a PhD candidate at Utrecht University, and I'm very happy to be here. I followed NetPlay's seminars in the past, and I found them so interesting. And yeah, I'm happy to contribute to it. And so this work is published already, and the data set and the code are available, and you will see the QR code appearing in random slides. So if you are interested, you can access to whatever is in there. So our research question is the following. So we want to see if negative interactions reveal something about polarization that when we only have positive interactions, we don't see. So that's what we want to find out in this work. And the title of the paper suggests that we find extreme users when we look at negative ties. But of course, we'll explain a bit more about it later on. First, I want to talk about my motivation of studying polarization on social media is because these online ecosystems, together with traditional media, are very crucial in creating polarization and increasing polarization in shaping public opinion, and also the spread of fake news. Like also, if we look at what's happening right now, for example, at the moment there is the global Sumul flotilla that is trying to reach the coasts of Gaza, but already we see two different ways that this action is portrayed by different traditional media, and this is even amplified on social media, and this is polarizing users in social media. So that's why I'm really interested in studying this topic, and like going to a more like scientific literature background. If we think about social media, it's hard to find data sets where negative interactions are available. So if we think about Twitter, not available anymore, now X, but in there are no dislikes, let's say. It's only available likes and stuff like that, or mentions or reposts, but there is no clear negative interaction like stated there. You can infer them doing some sentiment analysis based on comments, on text, but per se, there are no dislikes or downvotes. But there is this, there are different sociological theories, and one of these is this emotional information theory, where negative sentiment can be a strong indicator of negative interactions between individuals. So what we do is to assume that when we have a negative link, there is a symptom of discord or tension between the two users. And lastly, most of the studies on structural polarization, so polarization based on the structure of the network, have focused on unsigned data. So when you only have positive interactions. Other studies have shown that polarization when you have signed data can be like comparable or related to structural balance theory. that in 2 words means the enemy of my enemy is my friend. Of course, it's more complicated than this, but that's not the main focus. But so the difference between these two types of polarization that by Zachary Neal are called weak and strong polarization, so unsigned and signed polarization, are the following. So when you have unsigned network, like most of the networks we consider, it's mainly that you have groups that are highly connected inside the group and not very connected among groups, while in signed networks you have internal coherence, so many positive links within a group, and negative links between two groups. So that's what we mean with polarization in signed data. So what we want to see is that if having these negative connections, we find something different or not. We do it on a data set, which is straight from this platform similar to Reddit, but it's a Spanish platform. It's called Meneame, and it's a very niche left wing, but a bit more into between tech, people into tech platform. It's not very big, but we like it a lot because data are freely available. And this type of positive and negative interactions are disaggregated, unlike Reddit, I'm sorry. And we scrape data from December 22 to August 23, and they are available on Zenodo, so you can play with it. And so as you can see, we have a post or a story coming from a certain news outlet, here abcd.com, and then you can upvote the story or downvote the story. Importantly, to downvote, you have to report as a spam, because those are the guidelines of the platform. While you can also up and downvote to comments. So that's what we are going to use in this work. And as I said, the research question is, what are these negative interactions telling more about polarization? And this is the plan. So we first divide the posts into topics, and because we think that between different topics there will be different alignments, so we don't assume issue alignment by default. And then we divide the network, like we create these vote networks. I'll tell a bit more later. Then we apply embedding methods, which is a sort of dimensionality reduction. And one is only considering positive links, which is correspondence analysis. And the other one, SHIP, is also considering negative ties. That's why we use both methods. And in the end, we compare them to see if they produce similar results or not. So that's what we do, basically, and what I'm gonna talk about. Topic modeling. I first started looking at their topic, which is very nice, but there are so many parameters to tune that I was getting different results every time, and we wanted very robust topics without having some spurious text in each topic. So we also used the hierarchical stochastic blob model to do topic modeling. I'm gonna go fast on this part, but the idea is that we get some topics from both, we reduce the number of topics, we do some manual validation, and then in the end we get 7 topics that are quite robust. And we focus on the first 2, so broad politics and the Russia-Ukraine conflict. While also we also study the rest, but we focus on these 2 in particular. Then we construct the networks. So the first one, user A votes to a post coming from the news outlet abcd.com. So we create a link between the 2, between the person, the user, and the news outlet. And this is a bipartite network. Meanwhile, we also have a user network. So we have user A voting to user X, the comment of user X, so we connect them. So that's not bipartite. So we use these two networks to then do the embeddings on it. The first type of embeddings is correspondence analysis. So we have a matrix, like a matrix where we have each user and the news outlets, for example. And then we do SVD, so singular value decomposition, and we only have unsigned data, so only positive links, positive votes in the case of our network. While in the case of SHIP, it's a spectral embedding method and takes signed data and is based on the minimization of the repelling Laplacian, which is a Laplacian specific for signed networks. So what we obtain, and this is the type of plot you are going to see in the next slides as well, is this type of plot. So we have on the x-axis, we have a dimension created by SHIP, and on the y-axis, the one by CA. So each user and news outlet is embedded in this space. And this is the way how we compare them. So for example, if we look at news outlets, so it's the same plot as before, but it's in the two topics, so Russia, Ukraine, war and politics. And we see that, for example, if we look at SHIP, is finding these outliers here, and these outliers are Russian propaganda news outlets. And both SHIP and CA are finding this outlet which is pro-army. So instead, if we look at the topics of politics, we see that they are quite aligned. So it seems that they are both finding the same kind of a left right wing spectrum when we look at politics, but when we look at a more specific topic, they find some outliers that are specific of the topic, and they are not really, in this case, left wing, and in this case, I mean, it's on a different dimension with respect to the rest. So what we do, until now, we don't know what's left and what's right. I mean, we can have a reasonable guess, but we don't know for sure. So we compare with external sources. We could scrape some data from Twitter. I'm not going into this that much, but we managed to have some type of validation based on Twitter and based on Political Watch, which is a platform that classifies news sources in Spain, among other things. And what we see is that if we look at here, if we look at the topic of politics, they kind of, both SHIP and CA align with what we find on Twitter, which is interesting because in this way we give a directionality to the axis of both. And it means that, yeah, so we find what's left and what's right. And if we look at the Russia-Ukraine topic, we see that they are not so aligned. So it means that on these specific topics, news outlets are not exactly as for broad politics. Yes, that's what I said. And then we do the same, but instead of looking at news outlets, we look at users. So each dot here is a user, and this is the embedding with SHIP, and the other is the embedding with CA. And what we find is that for both topics, CA and SHIP are strongly correlated to each other. So generally, they find the same thing. But if we look here, we see that there are some outliers. If we look at SHIP, and these are people that vote positively to these Russian propaganda outlets that I showed before. And these are the people that vote positively to that pro-defense outlet. And here, same thing, but these are people that vote positively to far-left media. The color of each dot means how they vote normally. So we see not a lot, but you can kind of see that these dots are red also here. And it means that these people vote negative a lot. So SHIP finds those people that are more involved in negative interactions, and they stay at the extremes. So people really left wing, or people like that are really voters of these Russian propaganda outlets. So generally they find the same thing, but if we look at the extremes, SHIP is showing something more. That's what we get from it. And even more, if we look at the voting behavior, we see that in-group votes are always positive, and that's what we expect. So on the diagonal here, out-group votes are negative, mainly from the left to the right, and not really the opposite, because there are more left-wing people on the platform. And it's interesting to see that CA, even though we don't give information on the negative links, still finds this negative out-group voting. And because CA assumes that when you don't have any value, assumes that there is going to be a distance. So it's kind of inferring that every absence of a vote is going to be a negative vote. So that's interesting to see that also in this type of voting behavior. So to summarize, what we find is that signed and unsigned networks provide a complementary insight on polarization. And even if we have such a very specific left-wing platform, we still find the polarization. So we find the left and right, and with these two approaches. In particular, if we look at only positive interactions, CA, it's embedding users in left and right political spectrum. So my suggestion is, if you only have positive interactions, use CA because it works quite well. While if you also have negative interactions, my suggestion is instead to use SHIP, because SHIP is finding already what CA finds, plus it's also finding these extreme users that engage in hostile behavior that you would not find if you only look at positive interactions. And that's it. My data set is there, the paper is there, and I just want to thank Shazia, that is also first author with me of this paper, and also my other co-authors, and thank you for giving me the opportunity to talk at NetPlace.
Thanks a lot, Elena. It was really interesting. So, do we have questions from the crowd? Yeah, we have a lot of reactions, a lot of applause for Elena. Do we have some questions? Otherwise, I can start with some details. I don't have any deep question, but just a few details. I didn't get, maybe you said that and I missed that, but I didn't get why we were talking about the news outlet, because in this specific platform, you can just like reshare news from other news outlet, or how does it work?
I was muted. Yeah, basically, it's a platform where people share news from, let's say, I don't know, some news outlet, and I think the title, they have to write it and also write a short description, which is neutral, let's say, while the comments are more real comments. So in the description, they have to say, in this article, they talk about something. So it has to be neutral, while the comments are comments, let's say.
Okay, and so basically, like the upvotes and downvotes are on the news itself, not on the really on the post in that case.
Yeah, so it's an interesting platform because they don't have an algorithm. It's all self-organized in the sense that, yeah, so the idea is that they should press report, so downvote only when it's a spam, fake news, or something similar. That's not what happens, but so it's really crowdsourced. sourced in the sense that then articles that have a lot of positive votes, but also a lot of interactions, go to the main page.
Okay.
So it's interesting because there is in theory no algorithm, but it's chronological compared to other
Mhm.
platforms. And yeah, you shouldn't report if it's only something you don't like, but that's what we see that happens. So
Yeah, yeah. Yeah, and that's I think what makes the platform also interesting because it's like a real negative link, let's say.
yeah,
And
exactly. In
another,
the comments, in theory, they can also downvote if
yeah,
they
yeah.
don't like. So, but it's interesting that we see actually the same in the comments and the
Mhm.
posts. So
Nice. And do they have APIs or it's like manual scraping?
I think it's manual scraping. I didn't do it personally, but
Okay, okay,
no,
okay.
no. Manual.
Another, I don't know if we have in the meantime some other questions from the crowd. Yes, Kamal?
Right. Thank you for a very interesting talk. I'm wondering, you mentioned you did used HSBM, how it stochastic block modeling for community detection, I suppose.
Yeah.
Did you do this on the which type of network, the bipartite or the user to user?
No, so there is this the paper by Gerlach and Pischotter and Altman, where they apply the HSBM for topic modeling, and the idea is that you create a bipartite network of documents and like text and titles, or in this case, the title of the for yeah document, and then let's say in the title there is HSBM, and HSBM is going to be connected as a word. So it's a bipartite network on which you do community detection. So document words. That's the bipartite network. And then we do hierarchical SBM, community detection, and then topics are found in this way. It works quite well. So but of
I had
course, you have different hierarchies of the community detection, so you have to understand which one you want to choose because yeah. But in general, like what's a topic? That's the problem. Like can be very vague or it can be more like it's hierarchical by nature as a question, right?
yeah, yeah. And you just need to get a community partition that's good enough, and they need to move on, right? I have a second question. Did you do like the signed network on both sentiment analysis and up and down votes, or just one or the other?
No, only on like only with the votes. Yeah.
Okay, I see. Would you guess that they generally correlate, or or has there been research that shows that they're not necessarily always?
Yeah, so the thing is that with the sentiment, at least what I try to do often gets like neutral because not all the text is really positive or negative. Like if I say, okay, and that's my comment, then how would you classify it? Or in general, like most of the text becomes neutral. So it's like what we wanted to use is given that finally we have like a explicit positive or negative interaction, try to use that. I'm not sure if it would be different. I think that these embeddings are change quite a lot based on what you have, but that's why we don't really, I mean, we mainly look at the correlation because per se it's hard to give them a meaning, right? So we look at the correlation to check if they show the same patterns or not. Thanks for the questions.
Yeah, thank
Just
you.
out of curiosity, is the user-to-user network directed or undirected?
It's not user to user. You said
Yeah,
it's not. We saw that there is hardly any
yes.
difference in sign. So
Mhm.
if I vote to you positive, it's very hard that you vote to me negative. We checked and it was really not a lot. So,
Okay.
and we had to simplify a bit. So, yeah.
Makes sense. Ale, do you have a question?
Yes, so thanks a lot for your talk. Probably I missed this, but did you do any cross-topic analysis, or you just looked at single specific topic like the war or politics?
Yeah, so the thing is that this platform is not so, I mean, there are not so many people on it. So
Yeah.
it's hard to find the same users in different topics. So we just compare them in this way, like side by side, but not really that much together. Yeah.
Okay,
Not
yes.
such a dense populated platform compared to Reddit, for example. So
Yes, and still also in Reddit, it's not so easy. I mean, you have some users, but there are not so many compared to the whole population.
yeah.
I mean, it also depends on the topic, but still. Okay, thank you.
Thanks.
Okay, so if we don't have any urgent question for Elena, I think we can go through the discussion part. So Elena, if you want to share your slides for the discussion, yay.